All right, in today's lesson, as promised, we will start working on the caterpillar's limbs. And so I did some prep for this lesson, and as you'll see here, I've kind of placed some limbs around the body, sort of like the way I'm imagining them being placed. And so that's it, right? We're just making the limbs and the limbs are there. So, well, no, okay, but this is procedural FX toolkit, right? So obviously we want to do this procedurally, and that's what we're going to do specifically in today's lesson is create a procedural distribution system for placing these meshes kind of along the body of the caterpillar. And so if we come over to the whiteboard though, we'll see it's not just the limbs that we actually want to place. This is kind of a drawing I did for a previous lesson's thumbnail. This is roughly the level of detail I'm kind of thinking we can add here. There's going to be some horns, and there's going to be some markings on the caterpillar's body also. Not necessarily these ones, but we'll have some spots along the body. And we're going to have a more sort of detailed body shape, not quite as simplistic as what we have currently. So every time we change these things, we don't want to have to manually place these over and over and over. We want to create a procedural workflow to do that. But there's actually a bigger problem that arises from the fact that I manually laid these out, which is that if I turn on the animation that we set up last time, we'll see here there's a huge problem with this, which is that the animation is totally broken. I mean, it looks kind of cool actually. It's just kind of an interesting looking glitch, but it's not working at all, right? The body still works, but if you look closely at these limbs, you may see what's going on here is that the body animation is being copied along each one of these limbs. So each one of these limbs is doing the exact body animation as if it is the body. And so it's moving kind of the right direction because we're applying these offsets in world space. But you can see, right, there's like a segmented move we want to have happen on the body from back to front. And you can see that it's turning the individual legs into those segmented pieces as well and kind of cascading from tip to base for each of one of those legs. So if you think about the reason why that's happening, because we are using the model's parametric coordinates to drive the animation. So these are just their own little models, and so they think that they need to use the same animation as the body. Now we could just try turning the animation off on the limbs, but that will cause another problem. So if I just create a copy of this material and I call this caterpillar body, keep the animation on that, and let's assign that to the body, and then let's turn off the animation on this one, you'll see, right, we don't get that glitchy behavior on the limbs, but now they just don't move at all. They're not following the body like they should be. They should be attached to the body. And now eventually these pieces will have their own animations that play independently of the body, but we do need to apply the body animation to those limbs. We just need to figure out the correct way, unlike what's currently happening where it's sort of being done in a glitchy fashion. So today we're going to solve this issue of the procedural workflow. We're not going to look at the animation issue per se, but my claim is we'll be able to solve both of these problems kind of with the same solution. Now there's going to be some extra work needed to get both of them done, but it's going to be using the same approach either way. And so let's first focus on this issue of the distribution, and then we'll work over to the animation stuff in the next lesson where we'll also kind of finish the modeling pass. And so let's just get this started by refreshing ourselves on how these models are set up, okay? Is that we are doing this parametric modeling with two different parametric coordinates, right? We've got our V parameter or coordinate that is controlling a lengthwise path, right? So that's our V parameter, controlling where we are along this path that I've drawn in blue there. And then we've got a U parameter, which is controlling where we are sort of along this shape that's being extruded along that path. Okay, so that's kind of our two different parametric coordinates that we've done, that we looked at a lot in this course. And now for this distribution system that I want to set up, I want to start distributing the limbs, kind of like what we have currently as that sort of manually set up test that I showed you before. We want to start distributing limbs across this. Let's say this is the body, right? So maybe we want to put a limb here, okay? And if we do that, my proposal is let's specify where we want this limb to exist, not in like 3D space, but in parametric space. So if you think about where in the V coordinate of this parent we want to place this limb, where I drew it, it's about halfway between the start and the finish. of the body lengthwise. So that would be 0.5 in the v coordinate. And so then let's say like the u parameter would start here and then it kind of winds around this way, right? So let's say this is 0 on u. So the way I drew this, the u coordinate where this limb would be placed would be 0. So this would be placed at 0.5 in the parent's uv coordinate system, okay? And then we could place other limbs, like we could place one here, and that would be at 0.5, because u would have wound around half of the way, all the way back, so that would be 0.5 in u, and v would still be at 0.5. So then we could keep placing limbs here, like this could be like a lower value in the v coordinate, where this could be maybe like 0.25 in v, and then we could have one over here that would be like 0.75 in v. Hopefully you get the idea, is that the way I want to design this distribution system is let's do it in the parametric space of the parent. And then what we can do as well is we can then have sort of a recursive element to this, where on this limb now, we could then say, let's say this is a leg, then we could start distributing like toes along the length of this leg. So we could put a toe there, we could put a toe there. I don't think we're going to actually do that for the actual caterpillar mesh, but we want to build our system so it can handle things like this. So I'll just use this toe metaphor throughout this as we're building this system. And then beyond just this toe level, then we could start distributing, like let's say like a claw could be coming off of the toe. And so basically we want to set up some kind of system where for whatever type of object that we're distributing, let's say the claw, it will have like a rule that every time a toe is spawned, we need to distribute a certain number of claws at certain locations on that new toe instance. And every time we create a new leg instance, we need to create toes for it, etc. All right, so I've set up a new folder in our scripts folder, and I've called it MultiModel. And I basically just put some empty scripts in here that I think we're going to use for this system. And so let's just dive into these. So the first script I made was called just MultiModel. And so this is going to be like the high-level entity that's going to be actually distributing those limbs into our scene in sort of an automated version of something like we have here already. And so that's going to be the output of this, is that it's going to have some kind of generate function. So let's start just commenting what it's going to need. Now the next script that I set up would be this MultiModelGroup. So this would be where we would say, like for example, our toe would be a group in that example. And that would say, you know, it would also have some kind of generate or distribute function to it. And it would be doing that on a parent instance. Okay, and so then that kind of leads us to this multi-model instance. But let me just first say about the group, there needs to be also some rules about when there is a new parent instance, what is the mesh that we want to distribute? Like what's the model template that we'll use to instantiate? And then also there would need to be rules as far as like how many instances to generate, where in the parametric space to generate. So that's kind of the logic that would live on this group script here. And then the instance, I kind of mentioned already, this would just be basically like models with some kind of metadata as well. What's really going to be important with this is that we need to track where in the parametric space that we branched off of our parent. And so then we also, as I said that, obviously we have to add a reference to the parent and then maybe some other stuff too. And so I think those are the three components that I have in mind for this distribution system. So let's get started coding this. And I think we'll start with the multi-model. Let's just go in like a top-down way. I think that works pretty well generally for a implementing a little system like this. So let's create our generate function. We'll just call it generate, and we'll add a context menu like we did with our meshes. We'll just call this generate. For something that's going to be creating objects into our scene, one pattern I really like for this is to track a generated root, right? So here we can place everything we're making in this function. We can put it under this object. And so then we can say at the beginning of this, we can say if this generated object does not equal null, we can destroy it immediately. That way, basically, we can sort of regenerate, and we'll just get rid of what we did last time in here and then we can set it to null there. And let's just make sure this is kind of like serialized. We can hide it in the inspector as well. Okay, so then we just need to create a new object, do something like that. Okay, and then we can place it underneath the transform of this object. So now I think what we need to do is look at all of the multi-model groups that are underneath this object, and kind of like what we did with our modifier stacks when we were doing our modular modeling. We'll have a bunch of groups under this object that determine the rules for what needs to be generated. So let's get those. We can just say get components in children, multi-model group, and we can include inactive. They might be disabled in the scene, and we can just say multi-model group, all groups, like that. Now here, what we want to do is look for any group that does not have a parent assigned to it. Basically, if we go back to our diagram here, right, this would be like the body. So the body would be a root level group where it just generates no matter what, and then everything else only generates on some other group instance. So let's iterate over all of our groups. And now we can say if group.parent, which doesn't exist yet, does not equal null. If it does not equal null, this is not a root level group, so we want to skip this group. Okay, so now we are only root level groups here, and then we can say group.generate. And I think this generate function is going to spit out a bunch of instances. So we can just say for each MultiModelInstance, inst in group.generate. We can say inst.transform .parent equals generated.transform. Okay, so I'm just kind of like implementing this from a top-down level. As you can see here, right, we need to add some of this functionality, but this is just the way that I find is useful to implement a system like this. Go from the top down and just see what needs to be done, and then you can kind of just go from there. Okay, so obviously our group needs to have a parent. That's going to be another group. So we'll say public MultiModel group, parent, and we already knew this was going to have a generate or distribute on a parent instance. Now I didn't provide a parent instance here, so it's going to be able to take a null parent instance because this is a root level group. You want to be able to also generate this without a parent instance. And so the way I'm going to do this, I'm just going to use this built-in feature to highlight this problem, and we'll use the automatic stub generation for the function. And so this is giving us an IEnumerable multi-model instance, which is exactly what I wanted it to do. It brought in this generic collections namespace. So this is great. I'll just change this to public. And what we do need to do with this, though, is to give a multi-model instance, parent instance, and we can just default that to null so that our invocation here will still work correctly. And if you have not seen this IEnumerable before, it's pretty cool. Basically, it will allow us to, at any point during this body of the function, we can do something called yield return. And so that will sort of spit out a multi-model instance from our method. Unlike regular return, though, it does not break execution of our method. So we can keep going. And this is a way you can kind of programmatically generate a collection of things that's going to be something you can enumerate over. Okay, but so for now, let's undo that and let's keep this as not implemented for now. So I think what we need to do is we need to create a template, which we can make a parametric model. And so this will be like our template model. This group is going to want to instantiate multiple copies of this template, essentially. We also want to, let's say we want to do something like a grid. So we can say n iterations u, n iterations v, and then we can say like give it like a min u and a max u and a min v and a max v. And we can do it in like a grid-like fashion here. So we can say something like for int I equals 0, I less than n iterations u, I plus plus, and then do the same thing for v. And we can use j as the iteration variable there. And we typically use v as the outer loop, so why not just make that consistent? Okay. So now what we want to do is we want to yield return some instance inside here in the body of this inner loop here. So we need to figure out what's the v coordinate at which we want that instance and what's the u coordinate. Okay, so we can say float v equals I divided by n iterations v minus 1. And then we can just use that sort of like, we can call that a raw v maybe. Then we can create a v from that where we interpolate between our min and max v with that raw v. So we've got our v coordinate. Let's just do the same thing for u. Now, I mean, technically we may want to add some ability to do like handle that looping aspect of the u coordinate that the v does not have. But I think in the cases that we're going to be working on today, we're not actually going to deal with that. So let's just do it this way. And then if we need to integrate some special looping handling there, we can do that. Now, the one thing also that we need to make sure of here is that this n iterations v minus 1 could cause problems if we just want to do like a single iteration of v and make a ring around u, for example, or if we want a single iteration of u. This will be dividing by 0. Okay, so we just need to make sure here we can say n iterations v equals 1. We can just use 0.5 to just give us like a midpoint between these two values if there's only one iteration of v. Otherwise, we'll get an error because we're dividing by 0 there. So then here we can say n iterations u, and we'll use the raw u. So now what we need to do is we need to generate some instance here, and then yield return it. Okay, and then I think actually what we need to do after that is for this new instance that we generate here, we then need to look at, are there any children groups of this multi-model group here? Does this group, let's say this group is a leg, then it would have a child group, which is a toe. So we need to have some concept of not just the parent, but the children groups of this group. And then what we want to do is, let's just sort of flesh that out. Now we can say child groups like that, and we can make this a list. And we can kind of have this working behind the scenes because we want to manually specify the parent, but then the children we want to auto-generate from that. So then we can say for each multi-model group, child in child groups, we want to then get our child to generate itself on this new instance that we're generating. So we can just say MultiModelInstance, new inst, and we can say we'll fill that in later, but we can yield return it. And then here we want to generate our child group on that new instance, but that's going to itself is going to give us this IEnumerable of instances. So then what we can do is here, we can then take each multi-model instance that comes off of that. We can say child instance in, right? And so this is where that kind of recursive element is going to come into play. We can then yield return that child instance. And so we basically, from the multi-model itself, we're just going to need to generate our root level groups. And then all of that sort of recursive functionality comes from generating this group here. Now we have to figure out what we want to do here, where we create our new instance. So let's do that. And we can, at this point, we can kind of get rid of this. Actually, before we do this new instance thing, let's figure out this child group thing. And let's just get these high level scripts done before we dive into this lower level thing. So I want to create a list here and have this get managed. So I'll just say like clear children, or I can say like set up, let's call it that, because then that can clear our children, but then they can also build the template model, because we just want to make sure that this template is up to date with whatever changes that have been made. And then let's just add the ability to set up this child from outside. Then I'll just add like that to the list, okay? And let's do that from our multi-model itself. So here I've got all the groups. So let's just do a couple iterations on this. I don't know if this is the most efficient way of doing this, but we'll just do it this way. So we'll say for each group and all groups, we'll first initialize it, or I think it was called setup. And then we can then do something like this. We can say group.parent.add_child of group. And this is only going to be if the parent is not equal null. Okay, so that should have now our group is basically done, other than the fact that we need to now initialize some instance here. So we can say here, let's take our template model and instantiate that, and we'll use Unity's built-in instantiate function. We can take the game object and add a component of a multi-model instance in order for that to work correctly in one line. You know, we could maybe do that in multiple lines if that's too complicated, but that should work okay, I think. So this body here is mostly done, but what we need to do is actually position this new instance based on these U and V coordinates. And let's also make sure that we're tracking some of this information on this actual multi-model instance as like the metadata that I mentioned before. So let's come into the multi-model instance and let's create a branch U, branch V coordinates, and we can just create like a helper here. We could say branch chords, and we can just use this property accessor syntax here to just, if we want to get it as a vector, we can just kind of automatically return this vector that's constructed dynamically. And then we also want to make sure we're tracking the parent instance. And what else? Let's also keep track of like a layer, I'll call it. So this will be like 0 for our root level instances. And then if it does have a parent, then it will basically be the parent's layer plus 1. And I can actually, on this thing, make the accessor public, but we can set this privately as part of some kind of setup. And we can stub that setup function in actually. Before we fill this out though, let's just set those fields that need to be set from the group and then move on to the instance. So we'll say new instance dot branch U equals U, and then do the same for V. And then let's set the parent instance. And remember, this parent instance could be null. So we have to make sure that our setup function, we're handling that case. I think this should be done now. This group should be done. I think the multi-model itself should be done. So now let's just work on this multi-model instance. So I think what we need to do is let's set our layer first. So we'll say layer equals parent instance not equal null. Then we'll use the parent instance's layer plus 1. Otherwise we'll use 0. Now if our parent instance is null, I think we can just return here. I think that's pretty much all that needs to happen. But if it's not null, we need to then position this instance in the parametric space of the parent. So if we come back to our whiteboard, right, if we're placing like one of these limbs, we need to look at what position on the parent mesh corresponds to that UV coordinate where we want this object. We'll have to position it there, and then we also have to rotate it so that it's the up vector that we use to correspond to V. We have that kind of hard-coded currently, so that's okay. We want to make sure that the up vector of the particular instance is aligned to essentially like the surface normal at that position, right? You can see like the tube surface normal at this point is pointing off in that direction, and that's kind of how I just drew this limb coming off of that surface. So let's see if we can do that here. Let's get the model that corresponds to the parent. So we'll say parent model equals parent instance dot, and this should live on the group. So let's get the group from our parent instance. Okay, we didn't do that. So we need to make sure that we are tracking the group that generated this thing too. So we'll say MultiModelGroup group, so each instance knows which group created it now, and then that should give us a reference to this template model. And let's just make sure we didn't actually finish this. We needed to also assign a group here equals this. So as we're generating this instance here, this is the group that we want to assign onto our new instance. And this keyword, it's going to basically give you a reference to the object that you're invoking this method from. Okay, so let's go back to our instance setup here. So we've got our parent model, And so what we need to do now is we can call our vertex position. And in this case, it's not really going to be a vertex. It's going to be something we're positioning on that surface, but that's okay. And we'll just say branch U, branch V should give us a vector 3, which is positioned on that parent model's surface. So we can say spawn pos, but this is going to be in the local space of that parent model. And that parent is probably going to be transformed in some way. It's either going to be moved around or rotated or both. I mean, even right now, our body mesh is rotated, right? So we have to make sure that we're not looking at a local space spawn position. So we can call this in parent local space. Let's say it's very verbose, but it's descriptive. And so we can say transform that into world space, and we can use the world space to position this new instance. So we can say spawn pos ws equals parent instance transform, and then we can use this function here called transform point, and this is going to take any vector 3 in the local space of this transform and move it into world space. This should give us what we want. And then here we can just say transform of this instance position, and just use this spawn position ws there. Okay. Now we need to do the rotation aspect. So now we need to get a spawn normal in parent local space. Don't know if I like that name anymore. And then here we need to get the vertex normal. Now there's a problem here, which is that we never actually implemented this because we were just using Unity's built-in mesh vertex normal calculation. So we'll have to get to that in a second. It's not going to be that bad, but we'll have to implement this. Let's just finish this out first. We'll keep going top down here. So then here we'll say spawn normal ws, and we'll have to use this here. And here we want to use, rather than transform point, let's use transform direction. And we saw something similar to this in a shader already. Basically, if this parent instance is moving around as a translation, we don't want that to affect any facing vector, or that's just representing a direction rather than a position. Okay, so now we've got our spawn normal ws. Now what we want to do is set the rotation, and we can use this handy function here, from to rotation. Quaternion is just how rotations are stored in Unity. That's a whole other sort of topic. You can basically think of it as like an angle axis rotation. So it specifies an angle and an axis, but kind of an advanced math thing. So let's not focus on that too much. We can use this helper though, which we can transform our from direction, which we want to take our vector 3 up and transform it into this spawn normal world space. And I think this should work. So here, let's just go to our vertex position. Let's create a little sibling function for this. So we'll do our vertex normal kind of right below it. We'll just say this is not implemented for now. And let's just go into the whiteboard quickly, and we'll see generally how does Unity calculate those normals based on our triangle setup. And the basic idea is that a triangle will define the orientation of a plane in 3D space, right? If you think about the word triangulate, like you're triangulating your position, you can extend the bounds beyond just where the triangle lines are, and this will extend into infinity, and it will define an entire plane in 3D space. And the legs of the triangle point in different directions on that plane, which kind of defines where that is. So you have two different tangent vectors, which just means that it's parallel to that plane, is if it's tangent to the plane. And so then we can use a function called cross product, which will take one of those tangent vectors, and then we can cross it with this other vector that's tangent to the surface, which we can call the bitangent. And the end result of that will be a normal vector, which is basically a vector that is pointing 90 degrees off of that surface. And as we saw before, right, this could go sort of either in front or behind. So we have to make sure that we're passing these tangent and bitangent vectors in the right order, which is the same concept we saw as we were setting up our triangles, setting the winding order of the triangles. It's kind of the same concept. So that's a lot of terminology. Hopefully this makes sense, but we'll see as we're implementing it. It's really not that complicated, but I just explained how you'd calculate a triangle's normal vector. And let's go over here now. We can basically create some tiny little triangle essentially that's localized to this position when we're calculating just what's the normal at this position. Let's create first just get like this pos, which would be just the vertex position at this location here. Okay, and then we'll get two positions that are offset in either the U or V directions. And we just want to add some tiny offset, in this case U, in the other case V, and let's create something called epsilon, which will kind of just dictate the magnitude of that offset. We can just use some small value there. So then we would just do that, right? So we basically just want to create some tiny little triangle. And so then let's get our tangent vector, which we can use to point to this point from this pos. And then we can create a bitangent, which would be pointing to the other point, okay? And then we'll return a cross product of our tangent and bitangent. And then we just want to make sure this is normalized. All right, so we've got our vertex normal. I think we've got everything we need. Let's test this out and see what happens. Okay, so what I want to do here is just basically let's take one of these front legs, one of the hind legs, and we can use these as sort of like templates for the groups. And let's also actually take our base mesh and turn that into a template too. So we can create an empty object here that will be like our templates. We'll put those objects underneath that. And this way we could just turn these off in the scene if we don't want to actually see those templates, right? We could just kind of turn that off. And for now, we won't see anything, but we will in a second. And then let's underneath this, let's create our groups. So we'll create our multi-model group for our base mesh. And this one, we just want to have one iteration in both U and V, and it has no parent, okay? So that's good for our base mesh. And let's just put this also in a parent that we can call groups, okay? And then we can create, let's just do the hind legs for now. Let's just make sure the system's working. So we'll generate these hind legs on the base mesh as its parent, okay? And so here, we want to have two iterations on U. And if we look back here and see our U, remember I said this was like 0 and this was 0.5. I think we want these legs to be positioned a little bit on the underside of this. So if this is 0 and this winds around to 0.5, we kind of want this to be 0.55, let's say. And then we want to apply the same offset over here, but this 0 is equivalent to 1. So we'll say 0.95 we can use here. So this we can say is 0.55, this is 0.95. This will just basically place these on either side of the body. And then we can say we want 4 legs on each side of the body. And I don't really know what to do here. Let's just say 0.5 to 1. Okay, so we've got our group set up. Now let's also, to our actual caterpillar, add our multi-model. And let's see if this works. Okay, so we got something there. That looks rather crazy. I think with our hind legs, we need to assign the correct template first of all. So we'll do that. And let's see if our generate works here. Okay, so what I'm seeing here is it looks like our surface normal, it's pointing in the wrong direction. I think there may be some other problems, but right off the bat, we're spawning these kind of inside of this. So that's telling me our surface normal needs to have like essentially our classic winding order mismatch here. So if we do that, does this look any better? Okay, so that does look better. I don't know that this looks good though, but we have this at least pointing in the right direction on these ones that are spawning seemingly in the right direction. I think this is right because look, it's spawning on this kind of side of the mesh. And so I think that is right, that it's kind of pointing more forward in that case. And we can just tweak those coordinates where it's spawning. But I want to know why this is happening. This seems kind of weird here, that this is happening in this uneven pattern. So that makes me think maybe there's something wrong with our grid. So let's come into our multi-model group here. Here's the problem, is that here we're driving our raw U from our I iteration variable, whereas it should be driven by our J iteration variable. So that's just a classic copy paste fail there. So let's come back here, try that again. Okay, so now that's kind of weird back here. I think that's because we're going all the way to 1, so it's putting it on this tip. So let's try, rather than going all the way to 1 with our v coordinate, let's go to like 0.95 or something, from 0.5 to 0.95. And let's regenerate this. Okay, now ideally, I think we should be spawning these legs in the center of these segments. So that's something that we can take a look at next time. We're gonna keep working on this. For now, let's just test this so we can start playing around, right? If we make this like 0.6 or something like that, we should see a different result at least, which is, hopefully we should see these move more towards the back. Okay, which we are seeing. And then we can also move this, like let's say if we want to move it down the body more towards the base, we can change those U coordinates where it's spawning. We should see those move down, okay, which we do see. So this is working, which is cool. Let's also, before we wrap this lesson, let's just make sure that if we created like, let's say like a toe, no, not togue, toe, and then let's just create like a toe dummy thing here. And we can make that a radius. We can just kind of half the size of this thing. And we can have the toe spawning on the hind legs. And we can use the toe base template model here. Let's see if that will work. Okay, and so you can see there, now the distribution is crazy because it's just using the same distribution pattern as the legs are using on its thing. So let's maybe change that a little bit, but I think this is working, right? So we can say, let's do 3 iterations on U and just 1 in V, and then let's regenerate our objects. And so that's kind of working a little bit more like how I was kind of thinking that these toes should be spawned. There is this weird thing where like we have to maybe consider the role or orientation of these things. I don't think we're actually going to need to do that for this caterpillar mesh, so let's just keep that in the back of our minds. But I think this is going to work pretty well for our purposes. So this is awesome. We have our distribution system, and next time we can use that to fix our animation problem that we opened with, and hopefully actually model the limbs out. We'll see. So see you next time.